Hey guys, what's going on? Glove here. Welcome back to another video. In this one, we're going to be going right along in our Go series, and we're going to be going through control flow and how it works in the Go programming language. But before we get there, I do want to really quickly, hopefully help you guys out because I get a lot of requests for the code for certain things. So just wanted to give you guys a heads up. If you go over to my GitHub account, there will be a link for this in the description. At my GitHub account, I have a YouTube Go repository, and you can find from every video control flow, or control structures rather. It's already up, although I haven't pushed it up yet because the video is not up. But you can check out all of the code from all of my Go videos. So hopefully, hopefully that helps. All right, cool. So let's start talking about how control statements, you also hear it called control flow, works in the Go programming language. And if you have any experience with C or perhaps a C style or C-like programming language, this will probably look pretty familiar to you. The only difference is that it's going to be a little simpler. It's more consolidated syntax and a little bit cleaner. Kind of takes away what are really unnecessary characters or what could be considered unnecessary characters so that we can, again, write cleaner code, which is a really big selling point or goal of the Go programming language. So let's start off with if statements, and we're going to pass in a 3 and a 2. So we'll remember that, right? So this is a simple if-else statement, right? And we have if x, which is the first thing, which is 3, is greater than y, it will print this statement right here, x is greater than y. Otherwise, it will say it is not greater than y. And if we run this, we will get x is greater than y because indeed 3 is greater than 2. Okay, let's talk about cases where we can omit the else statement. So this part right here, right? So in the case where we are testing for an error, let's say, we can basically just return, because we'd be returning, right? You probably don't want to continue on if the code errors out. So in this case, because you would never actually get anything beyond, anything beyond this point. So in other words, this print statement will never get there, even though it's a legal print statement. We'll never get there. Or we could get there if this is not true, right? If this equates so error is nil, then we will get there. But let's see what happens, right? So something went wrong, which we know because we just printed out this error and we returned, but we never got to actually print out what the error was. Oh, well, okay. I guess I should have done this. We'll never get here to make it more clear what was happening. So my apologies. So we never print this out because we actually just return right here, which means that we don't need the else statement. We can omit it, which gives us cleaner code. All right. So let's now talk about the initialization statement and what exactly that means. And this is actually pretty cool. As far as I know, this is unique to Go, and it allows our code to be a little bit cleaner. In Go, in a for loop, and this you've probably seen in other languages, don't worry, we'll get there and how this kind of works in Go in the next file that we're going to talk about. But in Go, or in a for loop, you can have an initialization statement where you might set, let's say, I equal to 0, right? So in Go, in an if statement, you can do the same thing. We can say that error is going to be equal to new error, and then we can actually have, separated by semicolon, we can actually have our check right here, right? And so by doing this, we will get the same thing that we did before. Something went wrong, but again, right? What's interesting though is that this right here is now illegal. And the reason is because this error variable that we've defined here is scoped to only what is inside this if statement. And so it's a cleaner way, because typically when you're developing something, when you're writing code, you want to use the smallest scope possible when you're declaring variables and whatnot. And so this is yet another way that we can declare the variable, have it scoped to only where we need it to be scoped to, and also use that variable to actually check to see if a certain condition is true, making this now illegal, which is why you see this error. And the error is undeclared name error, because as far as Go is, that wasn't English. I'm sorry. As far as Go is concerned, this doesn't exist. All right, let's take a look at for loops. Okay, let's go here. All right, so again, we have our type person. We'll come back to that later. Let's talk about the different types of for loops and how you would write for loops, right? And there are three ways in Go that you can write a for loop. The one way is probably your traditional way that you're maybe most familiar with from other programming languages, which is that we have an initializing variable. That's what we're going to use to actually iterate. And then we have the condition, and then we have the iterator, right? And if we were to do this, I'm passing in x, which in this case is 10. If we were to run this, it would print out I is, and then whatever I is, which goes up to 9 because I have it less than x, not equal, or not less than or greater or equal to. All right, so the second way that we can do this is with just the condition, and we can set our initialization variable outside of it. And this is perfectly legal, right? So we set I is to 0, kind of similar to how we did before. And then we say that as long as I is less than x, keep going, right? And now what we'll do is we'll print out the two things. We're also going to, remember x rather, is 10. And so we're going to set I to be a random number between 0 and 20, okay? And then here we'll print out I just to see what happened. Basically, there's now a 50-50 shot of this equating to false, in which case the loop stops. So let's see what happens. I starts out as 0, it continues. I is now 1, it continues. I is now 7, it continues. It's still 7, but here we said it actually did 19, which means that this won't be true anymore because x is 10, so it stops, right? And this is totally legal. And this is kind of similar to maybe like a while statement in other programming languages. And actually, Go doesn't have any do while statements. So this might be a way that you can kind of get around that. All right, let's talk about the next way that we would write a for loop. And that way is just by like an endless for loop. There is no condition. It will just continue forever until you have the break keyword there. Don't worry about that. We'll get into that in, I think, switch statements, okay? So what we can do then is we can just print this out, and you'll see that this continues. You can see here it is still going. I'm going to cancel that so that it doesn't ruin something, but actually it shouldn't ruin anything because it's just an endless for loop, and that's totally legal as well. Okay. So let's talk about managing array iteration using the range keyword. And how does this work? Well, actually, I think in most Go code, you'll see the range keyword used when iterating over something as opposed to syntax like this. Don't get me wrong, there's still a use for this and a time and place, but this is really useful, really helpful, and you'll see it a lot. So what we're going to do here is we're going to create a new slice here, which is just a slice of integers, which will go from 1 to 5, right? And we'll basically say for k in range of I, which means for every k in I, right, print k, whatever it equals, right? I just did that, so we'll do this, and we get 1, 2, 3, 4. Don't forget k. Actually, k is not the value, k is the key here, so that's why that is happening. So basically, in other words, this is the index of each of these things, not actually the value itself. If we were to do this, if we were to do this, we could then say v, and we would then get the values as well. You can see that we get the values here as well, which is why we do have 5 here, and you can kind of see how that works. All right, so let's see another way that we can use range, which is now incorporating some structs. And so what we can do here is we can say that we have a variable I, which is equal to a slice of person. If you recall, I had this person up here that has a property of name on it, right? And we'll say that person is going to be, there's only going to be 2 people in this array, or in this slice, right? And so what we can do here is we assign to each position inside of that slice, we assign a new person, and then we're going to iterate over that person. Sorry, the hover things, the hover boxes in VS Code are kind of getting in the way. My apologies, but we can basically iterate through each of these people inside of this slice, and we can print out the different properties here, right? So here we have that index 0, which it makes sense because we had glove there at index 0, and then here we print out glove there, right? All right, so something else I want to show you guys is the blank identifier, which basically is saying, let's say that we want to assign something, but we're basically going to ignore it. We understand that something is returned or something exists, but we don't care about it. So we could do this by saying blank identifier, which is basically an underscore. Well, actually, in this case, here, I should do that differently. I'll do it this way, right? By saying, okay, we're going to ignore it using that underscore, and then what happens here is this is also valid. We only get the value here, and we understand that this exists, but we're going to ignore it. We don't care about it, and we're letting go no, and go is totally fine with that. And you'll see this blank identifier used quite a bit in different situations, and we'll definitely go over that at some point, not in this video, but it's very useful, and I would highly recommend, if you want to know more about it now, go check it out. All right, awesome. So let's now talk about switch statements and what they are, how they work. If you have, again, experience in another programming language, this is probably going to be pretty basic, but let's take a look here. So a switch statement allows us to do different logic based on, some specific piece of data, some specific value, right? So in this case, what we can do is, let's say that we have num. Num is an integer. That makes sense. Num is 2. So let's remember that. So in this case, we have a switch statement. This actually probably looks very similar to any other programming language in terms of the syntax here. This is just a really basic switch statement, is that we just go through these cases, and whatever case ends up being true is the one that we then go with. Num is 2. I want to know where the I is coming from. I is coming from here. All right, so I forgot to comment something else. That's something else out. That's why we were getting two different things there. But now we get num is 2, right? So that's right here. Okay. Let's talk about some different types of switch statements, or different ways to use switch statements, rather. So we can actually use a switch statement kind of as an if-else, and this is also considered idiomatic, by the way. So let's say that we wanted to switch, but we didn't say what we were going to switch on. We're just going to switch on the evaluation of some expression to true or false, right? And so then inside of our cases, we can actually put that expression that will be there, and whatever it evaluates to will be what we go with, right? So if we run this, we'll also get num is 2, or maybe I should say num is still 2, so that we can see that something different actually did happen. And the reason is because it is actually evaluating each one of these things here as it goes through this switch statement. And by the way, you'll always want to have a default statement as well, which I did have in both. Hopefully you don't actually get there. Hopefully your cases, fill the need there, and you'll always land in a case. But in the event that you don't, you definitely want to have a default case there. And I think VS Code will error out. I'm not sure about other editors, but just it's good to have. All right, let's talk about fall through, or actually, should I say, the lack thereof. So there technically is no fall through in Go switch statement, but you can kind of get around that by using these comma separated cases as part of the same case. And so in this case, we can basically say for any of these potential cases, do the exact same thing. And we don't have to write this out like this here, where we would have individual cases and we'd have to have a lot of repeated code. We can kind of just say, hey, for any of these cases, do this thing. So we kind of get fall through in that same sense. Okay, let's talk about break statements. I mentioned that we'd get back to this, and so here we are. Let's talk about how break statements work and what they are. So you've probably seen in other, other coding languages, a break statement as part of control flow. Basically, When you want to break out of a loop or break out of a switch statement, you use this keyword break, and it allows you, based on some logic, to basically break out and continue on with your execution or your control flow. And so Go is no different. These are actually less common, but they still exist, right? And we'll get to this in a second. So we have this idea of a basic break statement. And so what this is, I'm going to go and actually, no, this is totally separate because this is perfect right here, not dependent on our argument. So if I now run this, we will get to, well, we get to 2, but what's happening is that when we get here, we're breaking out of the switch statement and continuing on with our execution, right? And so, you'll see in some other language that you have a break in every single case. And we could do that if we wanted to, because I believe it will continue its evaluation going from here to here if you don't have the break. At least that's the way it works in other language. So I haven't seen anything that suggests it does not work like that in Go. Now let's talk about what a loop or a labeled break statement is. And we've kind of already seen it work, but in this case, we create a label up here. That's what this is called. And then we can break out of a specific loop or a specific label, right? And so what we're doing is we're saying that within this label, this for loop exists, okay? And then we're saying to break out of whatever this label is doing on case 2. And that's why we never get to this right here, right? We never get to this case 3, even though obviously this continues on, right? So if we were to, let's say, comment this out, now we won't ever break out of it, but we will, and there is an error. Where's the error? This isn't being used. All right, so now if we were to do this, obviously we'll get there, and we even print out we will never get here, right? But let's say that we didn't want to. Let's say that if a certain case was true, we wanted to break out of the for loop altogether, and we can do that by using a labeled break statement. All right, let's now talk about switch statements, or type switch, okay? So in this case, let's say that we want to check the type of something. So I'm going to take inside of this type switch function, we're going to take in some type, right, or some value perhaps, and it is of type interface, which means that it can kind of be of a wide array of things in the Go programming language. And so we're going to pass in then my name, Glove, Glove, and we're going to pass it in as a string, and we'll run this, and we'll say, okay, check what the type is, right? And then when you figure it out, go to the case that matches that type and print out the fact that it is a string or a bool or an int or whatever it is, and then also tell us what the actual value was, right? So if we run this, we'll get string glove, right? Now, let's say that we passed in something different, like for example, a 2. When we go back here, what do we get? We get int 2, right? Because we got to this case right here. And yes, I realize that I don't have a default after just saying how important it is to have a default. My bad. But nevertheless, you can kind of see how this works. So that's it for this video, guys. I hope you guys enjoyed and learned about how Go handles control flow or control statements. And I hope it was useful to you, especially if you're just getting started out with the language or even just getting started out with programming in general. So thanks for watching, guys. Let me know down in the comments if you like this video, or if you didn't like the video, let me know. And I look forward to seeing you guys in the next video next Wednesday. Take care. See ya.